Good afternoon, everyone. My name is Ram Karki. I am a mechanical engineering senior student here at Texas Tech, all the way from country of Mount Everest, Nepal. And here's my teammate.
Hello everyone, I am Vivek Dungana. I am junior computer science student here at Texas Tech.
Yeah, currently we have been working with the project named Real-Time Data Monitoring System with the NanoRobotics under the mentorship of Dr. Ma. And today we are very grateful to the TrUE organization for providing us this big opportunity to present our work in front of the delegate people and in this big platform.
We have been working on this project for like 6 months, which include application of computer science and mechanical engineering. And this is our prototype of our project.
What motivates us to get involved in this project was the massive earthquake of 2015 in Nepal, where thousands of people lost their life and there was a big financial loss. Let me show you the quick review of the video of that situation back in 2015.
We're just seeing some new video into CNN as you were reporting, where we actually could see some of the structures falling either during or after this latest quake, and it's just harrowing to see them come down so quickly and so incredibly destructively. It made me wonder about the places where all of those injured people, now mounting towards 20,000, are being treated.
I was there.
Imagine if we had better technology back in Nepal in 2015, we could save millions of lives and reduce financial loss by generating real-time data from the affected area. Okay, now let me give you some details about this prototype. This prototype consists of a lot of input and output sensor. The first input sensor is a camera over here. This is a sensor that can capture the video data from the surrounding or the incident, and it can transmit the video data from here to the Raspberry Pi. The second input sensor is IR sensor over here. This sensor can measure the distance of obstacle. So this car is smart enough to be like semi-autonomous. The third input sensor is a Bluetooth module. This Bluetooth module is used to establish communication between NanoRobot and this Android app we developed for our project. So this Android app is used to navigate and change the state function of this car. The next input sensor is temperature and humidity sensor, and it can send the data of temperature or humidity of the incident. And there is also one motor driver, L298 and driver inside this, which is powering all these 4 motors, and it is driving this robot. This is the brain of this project. It is Arduino, it is a microcontroller, and it is doing all the computation and calculations for this robot. And we have also used a Raspberry Pi for this project, and this is smart enough, and all the code are written in Python so that all the data and video informations are transmitted from this robot to our PC, a personal computer, or our Android app.
Now we are about to do a practical demonstration of our prototype. So here we got our app developed to connect our prototype with the Bluetooth module. We have the program TV remote that helps us to connect with the IR sensor. That's the programming part right there that we have done in Python. And here comes the major part of our prototype. That includes everything, all the sensors, cameras, microcontroller, and the drivers to drive our vehicle. So we are about to do the practical demonstrations by starting up with running our prototype with the help of TV remote. First of all, we are implementing our Python code in order to make it run. We are almost there.
Okay.
There it goes. So that's the real-time video data is streaming from our camera. It's the front part of our room right there that we are getting in here.
Okay, it looks like everything is connected right now. Now let me show you practical demonstration. How can I control our nano car using IR remote?
There it goes. At the same time, we are getting the real-time data in our laptop, as you can see on the screen. This is the video that has been captured by our camera. So we are right there.
That's awesome.
Hi. That's me again. All right.
Now I can also connect this robot by using the Bluetooth app over here.
So we are about to run our prototype with the help of the app that we have been developed. Now we are using our app to control the prototype, and at the same time we are getting all the real-time data of the surrounding. Now here comes the play of our IR sensor. Whenever the distance between the obstacle and our prototype is 25 centimeter, it changes its direction by itself and navigate to the new directions, as you can see here. That's us again. Looks like it's approaching towards me. That's me right there. All right. All right. We end up here. So all those data and information that we have collected with the help of our sensor cameras have been stored in our laptop here that we are going to show in a little bit. So we are able to get all the real-time data of our environment with the help of all of our sensors, and that had been stored in our computer. That's the video we have captured from our camera, and all the informations like the temperature and all other informations that we have been capturing can be accessed remotely. That's us right there again. Okay, let us imagine the similar situations that we could have been use our technology to send our nanorobot to the affected area, like the similar way that we saw in our demonstration. So it will help us to generate the real-time data of the affected area and give us the real-time data streaming, and we can access them remotely, so we can helps us to take the better decisions to minimize the loss and human casualties. To convince you guys about the effectiveness of our prototype in terms of its application in daily life.
Okay, now let me talk about future plan of our prototype. This prototype is in perfectly working condition, but it got some limitation over here. The first thing is it is using two-dimensional camera, which can only sense the two-dimensional data of the environment. In the future, we are planning to use this RGBD camera, which can generate three-dimensional data of the environment to better sense the environment and send all those data to this controller. The second problem over here is we are using Arduino and a Raspberry Pi over here. These are perfect for like small applications, but they are not suitable for large amount of data processing and on industrial level. But we do have solution for this. We are planning to replace this and Arduino and Raspberry Pi using a supercomputer Jetson, which can handle millions of data processing calculations, and it is also used on the industrial level. And by combining this camera and Jetson and implementing concept of computer vision and mechanical engineering, we are planning to make this prototype fully autonomous.
After updating all this new technology, we are trying to expand the application of our prototype in terms of industrial level. That helps our society to grow, and at the same time, it gives us the opportunity to appreciate the beauty of robotics in the 21st century. Finally, we are very grateful to Dr. Ma and Texas Tech University for providing us this big platform to learn and grow.
Thank you so much.
Thank you.